So now we will talk about solving equations that have variables on both sides. So this may look daunting, but it's really not. You know how to do everything that you need to do in order to solve these. It's similar to a multi-step equation because it has multiple steps. So we're going to talk about identity and contradiction. We're going to talk about both sides of the equation. We're going to talk about doing opposite operations, and we'll talk about just the nature of multi-step equations, right? So because there's variables on both sides, we're going to collect the terms much like we did with multi-step equations. Only this time, you have to remember the main idea of algebra, right, is that you do the same thing to both sides of the equal sign, both sides of the equation, right? And so whatever you do when we're moving variables from one side to the other, it's best to do it so that you make everything positive if you can. And we'll talk about that as we do it. So here we go. We have an equation. The variable n is on both sides, right? And so in order, much like before when we moved, so if we were moving this 6, we would just, since it's a positive 6, we would just subtract 6 from both sides because it moved this whole term. So when you're moving a variable from one side to the other, you're really just moving the whole term. So you're not dividing yet because we have to group these variables because they're on both sides of the equation. So we're going to subtract this whole term, which is 5n. The whole term gets subtracted from both sides. So we subtract 5n together from this side, and that's going to 5n minus 5n is going to equal 0. And then we subtract 5n from this side, 7n minus 5n is going to give you 2n. And then everything else stays the same until we begin to solve it. So we bring down our -2, we bring down our +6. And then now this just looks like a regular two-step equation. And we're going to solve it the same way that we solve regular two-step equations. Now that we have all the variables on one side and we have collected all of our variable terms, and when I say variable term, I'm just talking about this whole term here that has the variable attached to it. And so we're subtracting 2, so we're going to add 2 to both sides to move this 2 or get rid of this 2 on this side. So we get 2n is equal to 8. We continue to solve just like we know how. Since this is multiplication, we are going to divide by 2. So you divide both sides by 2, and you get the answer is equal to 4. So we'll do one more together, and then I'll ask you to try it on your own. So here we go. This is going to be, once again, a multi-step equation. So there's a couple of different ways to solve this. We are going to, in this case, once again, we want to always try and keep our terms positive. So we want to, if we're going to collect, if we're going to move something from one side to the other, we're going to move the smaller coefficient, remembering that the coefficient is the number that is attached to the variable. So we're going to subtract 3b from both sides. 3b minus 3b is 0. 4b minus 3b is 1b, or just b by itself. And then we get an equation that just needs to be solved. b plus 2 equals 0. So we're going to move the 2 to the other side of the equal sign. Since it's addition, we're going to use subtraction. And we're left with b is equal to -2. It works the same way with decimals. Do not let decimals scare you. All you have to do is make sure that the decimals stay aligned. Make sure that you don't transpose a number or move something around accidentally as you continue to rewrite the equation as you do it step by step. So here is the same thing. We have 0.3 times y on this side of the equation. We have 0.7 times y on this side. So we are going to move the 0.3 because we want to keep our coefficient positive, right? And it is a positive 0.3y, so we are going to use subtraction. So we're going to subtract 0.3y. Everything else stays the same. We haven't done anything to the regular numbers that do not have variables yet. So we get 0.5. This cancels out. Equals 0.4, because 0.7 minus 0.3 is equal to 0.4 minus 0.3. And so once again, now it's just another two-step equation. So this was a multi-step equation, but now that we've got our terms collected, our variable terms collected, we can now just solve it like a regular equation, right? So we have 0.4y minus 0.3 equals 0.5. So we are going to, since this is subtraction, this is a negative 0.3, we're going to use addition to get rid of it. So we're going to add 0.3 to both sides. These cancel out. 0.5 plus 0.3 is equal to 0.8. So now we get 0.8 is equal to 0.4y. Since we are multiplying 0.4 times y, we are going to divide both sides by 0.4. These cancel out, leaving us with y, and 0.8 divided by 0.4 is equal to 2. And once again, these equations, they may be written in a way that looks complex, but all you have to do is follow your order of operations, and you know how to do it all. So all you have to do is do it. It's just multiple steps. I think the most important thing here is when you're writing your equation and you're doing your steps, remember to keep the equal sign especially aligned in the center and keep everything else lined up too. So this is a really long equation that is just collecting your variable terms and then solving. So first thing we have to do is our parentheses. We have to distribute this -5, right? So we distribute -5 times 7 and then -5 times -2a. So bring down everything else on this side because we haven't done anything to this side of the equal sign at all. We did not do anything to the -1, and now we are distributing -5 times 7 and -5 times -2a. -5 times +7, negative times a positive equals a negative, so we get -35. And then -5 times -2a, negative times a negative, and we have a positive 10a. So now we just have all this kind of scattered out here, right? But now we're going to continue to collect our terms, right? So we have two variable terms on this side. And over here we have two non-variable terms. So we're going to collect all of these where they go. Negatives, so 4, we haven't done anything to 4 on this side because on this side of the equal sign, 4 is the only non-variable term. But we are going to collect a -6a plus 4a, that we collect those together. It is -2a. That's all we're doing on this side of the equal sign. Over here, we've taken -1 and we've subtracted 35, which gives us a -36. And then we did not do anything to the 10a because 10a is the only variable term on this side. So now we get this equation. We have variables on both sides. So we are going to collect. You can move the non-variable term first, or you can move the variable term first. It's whatever you're comfortable with or whatever just works for you. So we're subtracting 36 over here. So we're going to add 36 to both sides. These cancel out. 4 plus 36 is equal to 40. We did not do anything to the -2a, and we did not do anything to the 10a. But now we have to get the variable terms on the same side. We are subtracting 2a here. So we're going to add 2a to both sides, giving us 40 is equal to 12 times a. And we continue on with our operations. The opposite of multiplication is division. So we're going to divide both sides by 12. These 12s cancel out, gives us A is equal to 10 over 3, because 40 divided by 12 reduces to 10 over 3. It works the same way for fractions, right? So in this case, we have our distribution first. We need to distribute our 1/2 to our B and to our +6. We shall do that. And then we are not doing anything to this side yet because we're just working on one step at a time, one thing at a time. It may take up more paper, but it helps you to stay organized and to not miss a step. So we distribute 1/2 to B and 1/2 to the +6, which would give us 6 over 2, which reduces to 3. So now here we are. We have to get either our fractions on one side or our variable term on one side or our non-variable terms, which means, once again, just a term that doesn't have a variable. So this time we'll move our variable term first. 1/2 B by itself is positive, so we're going to subtract 1/2 B from both sides. 3/2 minus 1/2 gives us 2/2, which 2 over 2 is equal to 1. 1B is written as just B. Now we need to take our -1, and we're going to add 1 to both sides, leaving us with B is equal to 4. Now here's a very long one that you can try out on your own. So pause the video and see about working this one out on your own. All right, so here we are. The first thing that you need to do, of course, is your parentheses. So we are going to distribute this +2 to both the x and the 2, right? Bada bing, bada boom. 2 times x is 2x. 2 times 2 is 4. And once again, we have not done anything over here yet. So we're just going to keep on bringing it down and make sure that we write everything the exact same way. We get 2x plus 4 on this side of the equal sign. Over here, we have a single variable term and we have 2 non-variable terms. So we will group the non-variable terms. 15 minus 9 is equal to 6. And we didn't do anything here, so we just bring it down. Just bring it straight down, right? Now you have 3x plus 6 is equal to 2x plus 4. We will move our 2x together. The whole variable term gets moved, so it's a positive 2x. So we will move it by subtracting 2x from both sides. We have not touched our non-variable terms in this step. 3 minus 2 equals 1x. 1x is written as just an x by itself. So we have x plus 6 is equal to 4. And now we are going to move our non-variable term. Since it's a positive, we are going to subtract it. Subtract from both sides, and x is equal to -2. So here we're going to talk about equations that an identity is an equation that is true for all values of the variable. And this kind of idea is going to be important when we get to linear equations and functions. So we're introducing this idea as it's going to become important when we talk about functions, which we will do next. An identity is an equation that is true for all values of the variable. So there's no limitations. A contradiction is an equation that is not true for any value of the variable, so it has no solutions. And we'll look at some examples, right? Once again, an identity. When solving an equation, if you get an equation that is always true, the original equation is an identity and it has infinite solutions, right? So if something was 2 plus 1 is equal to 2 plus 1, 3 is equal to 3. That's always true. 3 does indeed equal 3, right? Same thing here, right? 2 plus x is equal to 2 plus x. You subtract the x over here from both sides, right? We want to move this x over here. So we're going to subtract it from both sides. And you get 2 equals 2, which is an identity, right? A contradiction. 1 is equal to 1 plus 3, 1 plus 2, 1 is equal to 3. Well, no, that's not true. 1 is not equal to 3, so that is false. Here, we're going to, once again, we got to get rid of the x on this side. Subtract x, we get 0 because x minus x is 0. And then x minus x is 0 plus 3. 0 does not equal 3. So here, we're just trying to find out if this is an identity. Is it identity? Is it infinite many solutions or no solutions? We're still doing it in the same way. We're still solving the problem in the same manner as we did before. We're going to collect like terms. Then we're going to collect the variables on one side of the equation and the non-variables on the other side of the equation to find our answer. So in this case, we're going to collect our terms. So here we have a non-variable term, a variable term, and another non-variable term. So we will collect our non-variable terms on this side of the equal sign. On the other side of the equal sign, we have a variable term, a non-variable term, and then another variable term. So over here, we will collect our variable terms, right? So 10 plus 1 is equal to 11. And then we bring down our minus 5x. Over here, we have 7x minus 12x is equal to negative 5x. And we bring down our positive 11. We have our positive 11 and we have our negative 5x. Now, we're going to, get rid of this negative 5x over here. We're going to add 5x to both sides. Negative 5x plus 5x is equal to 0. Negative 5x plus 5x is equal to 0. So we are left with 11 is equal to 11. That means this is infinite solutions. It's true. So the equation 10 minus 5x plus 1 is equal to 7x plus 11 minus 12x is an identity. All right, we're going to solve this one in the same way. Go ahead and do this on your own, and we will check it. So push pause. We'll check it when you push play. All right, so once again, we're solving it in the same way. We're going to identify our like terms, and we're going to collect them. We have a 12x, we have a variable term here, a non-variable term, and then another variable term. We will collect our variable terms on this side. Over here, we have a variable term, a non-variable term, and a variable term. So we will also collect variable terms on this side of the equal sign. 12x plus x is equal to 13x. Bring down your negative 3. 5x plus 8x is equal to 13x. And then you bring down your negative 4. So we're going to move our 13x. We're going to subtract 13x to get rid of it on this side. And it is going to get rid of it on this side as well. And we are left with negative 3 is equal to negative 4. And that is false. There are no solutions. Same thing. So pause and give this a try. This is great practice to practice everything that we've learned up to this point. All right. Same steps. Collect our terms and then collect our variables on one side of the equation. All right. We have a variable term on this side, a non-variable term, and then another variable term on that side of the equal sign. Over here, we do not have anything that we need to collect. So 4y minus y is equal to 3y. Bring down our positive 7. And we can, if you were adding, you can write it like this, or you can write it the other way. You can keep it like that. We are going to subtract 3y in order to remove it from this side, and it's going to remove it from this side as well, because 3y minus 3y is still 0. 7 equals 10 is not a true statement. There are no solutions for this one. All right, we'll do this one. So go ahead and do this one. Press pause, do this one, and then we will check it. All right, so in this case, we have similar equation. We're going to check, we're going to collect our terms. And then we are going to solve. So let's identify our like terms. Right? We have a variable term, a non-variable term, and a variable term is equal to a non-variable term, variable term, and non-variable term. So we will collect our variable terms on this side of the equal sign, and we will collect our non-variable terms on this side of the equal sign. 2c plus c is equal to 3c. Bring down our positive 7. We have our 3c, we'll bring it down, and then negative 14 plus 21 gives us a positive 7. And now I think we can already see that this is an identity, but we are going to subtract 3c to remove it from one side, and it will remove it from both sides. 7 is equal to 7. That is a true statement. There are infinite number of solutions for this problem. All right, so now we're going to do one word problem. John and Sarah are planting tulip bulbs. John has planted 60 bulbs and is planting at a rate of 44 bulbs per hour. Sarah has planted 96 bulbs and is planting at a rate of 32 bulbs per hour. In how many hours will John and Sarah have planted the same number of bulbs? And how many bulbs will that be? All right, so we need to figure out what we got going on here. John's already planted 60 and he's planting 44 an hour. Sarah's already planted 96 and she's planting 32 an hour. So when will what John has planted be equal to what Sarah has planted? All right. So B is going to represent bulbs. So when does 60 bulbs plus 44 bulbs per hour equal 96 bulbs plus 32 bulbs per hour? 60 plus 44 bulbs per hour equals 96 plus 32 bulbs per hour, right? Because we got our 60 bulbs that he's already planted, plus he's planting 44 per hour, right? BB per hour. And she has planted 96 bulbs, but she's only planting 32 bulbs per hour. So when will these be equal? Now we just solve it, right? We will collect our terms. 32b minus 32b is 0. 44b minus 32b is 12b. 60 plus 12b is equal to 96. We're going to subtract 60 from both sides. 12b is equal to 36. Now we continue solving. 12b equals 36. We are going to, since we are multiplying 12 times b, we're going to divide. B is equal to 3. After 3 hours, John and Sarah will have planted the same number of bulbs. Now, the second part of that equation asked us to find out how many bulbs that would actually be. So we have to go back to our equation and we have to plug in 3 anytime we see B. And we can do it for either of the equations. In this case, we'll do it for 60 plus 44b. So after 3 hours, John and Sarah will each have planted 192 bulbs, right? Because for each of the equations, we just plugged in 3 for B. So John planted 60 bulbs and then 44 bulbs per hour for 3 hours gives us his original 60 plus 44 times 3. His original 60 plus the 132 he planted in those 3 hours gives us 192. Same thing for Sarah. She had 96, but she's planting 32 per hour. Once again, it's 3 hours. 96 plus 32 times 3. 96 plus 96 equals 192. And so that is significant. It is merely following your steps, though. You know how to do each of these things. You just have to do them. And it is easiest if you line up your equal signs, right? Always line up your equal signs and make sure that you continue to write all of the equation every time for every step.